Hello students, today we are discussing green chemistry. So let's get start our interaction. Green chemistry was coined by Paul Thianest. The definition of green chemistry is the use of chemistry for pollution prevention by environmentally concise design of chemical products and processes that reduce or eliminate the use or generation of hazardous substances. The sustainable development, which is that meets the needs of the present without compromising the ability of future generation to meet their own need. To attain or to achieve the sustainable development by adapting the 12 principles of green chemistry. Out of 12 principles, today we see 6 principles. So let's see the principles of green chemistry. In that, first principle is the prevention, second one is the atom economy, third one is the less hazardous chemical synthesis, fourth one is the designing safer chemicals, fifth one is the safer solvents and auxiliaries, and sixth one is the design for energy efficiency. So we see one by one. So first principle is the prevention. In that, it is better to prevent waste than to treat or clean up waste after it is formed. For this, it is required to develop the zero waste technology. In this technology, the waste product of one system is used as a raw material for the another system. In terms of ZWT, the waste product should be minimum or zero. For example, the ash of thermal power station can be used as a raw material for cement and brick industry. Next principle is the atom economy. In that, the synthetic method should be designed to minimize the incorporation of all the materials used in the process into the final product, and only small amount of unwanted byproducts are formed. Due to this, the problem of waste disposal becomes very less. The concept of atom economy gives the measure of the unwanted product produced in particular reaction. To calculate the percentage of atom economy, we use this formula, that is the percent atom economy is equal to formula weight of the desired product to the sum of formula weight of all the reactants into 100. Next principle, that is the third principle, is the less hazardous chemical synthesis. In that, the reactions are designed in such a way that synthetic routes should be as safe as possible to avoid the formation of hazardous waste from the chemical processes. For example, we see first that the polycarbonate synthesis. The polycarbonate synthesis have the two parts. So first part is the phosgene process. In phosgene process, the disadvantage of this process is the phosgene is highly toxic and very corrosive. It requires large amount of CH2Cl2 and polycarbonate contaminated with the chlorine impurity. To overcome this disadvantage, the polycarbonate synthesis are prepared from the solid state process. In that, the diphenyl carbonate synthesized without phosgene eliminates use of CH2Cl2 and we get the higher quality polycarbonates. Next example of this principle is the earlier DDT was used as an insecticide for controlling the diseases like typhoid, malaria, which carries the mosquitoes. Disadvantage of the use of DDT is which is the harmful to living things. To overcome this disadvantage of DDT, now benzene hexachloride or linden is used. Fourth one is the designing safer chemicals. In that, the chemical products should be designed in such a way that they have less toxicity. The raw material which are required to get desired product should be less toxic. The preparation of adipic acid have the two parts. First part is from the in polymer industry. The adipic acid is prepared from the benzene. The disadvantage of this is the benzene is carcinogenic and it is volatile organic compound. To overcome this disadvantage, the In green technology, adipic acid is prepared by enzymatically from glucose. Next principle is the safer solvent and auxiliaries. In that, to minimize the percentage of waste after completion of reaction, it is necessary to choose safer minimum amount of solvent and auxiliaries for the particular step of the reaction. The main aim behind this principle is to use green catalyst. Many solvents are used in high volumes and many are volatile organic compounds. Their use creates large amount of waste, air pollution and other health impact. Finding safer, more efficient alternatives or removing solvents altogether is one of the best way to improve a process or the products. And sixth principle is the design for energy efficiency. In that, by using proper catalyst or microorganism at room temperature and pressure, chemical synthesis is designed due to use of energy is to be minimized. For example, for chemical synthesis, refluxing conditions required less energy. Also use of biocatalyst and by improving the technology of heating required minimum energy. Thank you.